students, next lesson, temperature dependence of resistivity and the resistance. Okay, so what is the effect of temperature on the resistance of the material and the resistivity of the material? In this lecture I am going to explain this. Okay, so as the temperature increases, as the temperature of the wire increases, so that the resistance also increases. So simple effect is that the temperature increases, the resistance also increases, but I will explain why. For example, if we have a conductor, if we have any conductor, any wire, and the current is flowing through that wire, so that current flowing through that wire, current means the number of charges that moves through the wire, and resistance is offered by the atoms, these atoms that in the conductor, they when the charges move through this conductor, when the charges move through this conductor, they will not go easily, they collide with the atoms of the lattice, atom of the conductor. These atom in the conductor, they resist, they oppose. This is the resistance. Resistance is the opposition due to the collision, collision between atoms of wire, and charges, and the current charges, charges. So this is the resistance. Okay, so when we increase the temperature, as temperatures increase, so that these atoms moves at the faster rate, their speed increases, because their temperature depends on the kinetic energy of these particles, depends on the temperature. So as temperature increases, the kinetic energy of atoms in the wire also increases, so they move more rapidly. The atoms move rapidly. When the atom moves rapidly, the chance of collision also increases. Chance of collision increases. So when the chance of collision increases, so the chance of collision between atoms and the charges increases, so that the resistance also increases. So this is how the resistance depends on the temperature. So it means resistance is proportional to temperature. We can say that resistance depends on the temperature. Okay, now next thing, I have to derive this formula. Rho t is equal to rho naught 1 plus alpha into t minus t naught. So in order to derive this equation, let me define first. I have to remove this one, then but I can move here. Okay, now, so for example, in order to derive this formula, for example, if we have a wire at the low temperature T naught, its resistance is suppose R naught. At low temperature T naught, the resistance is R naught. At temperature T degree Celsius, its resistance is RT, because we know that as we increase the temperature, resistance also increases, so that the difference in resistance RT minus R naught, it will depend upon two things. It is proportional to the change in temperature, del T. If you increase more temperature, the resistance change must be more, mean the change in resistance, change in R, is proportional to change in temperature. More you increase the temperature, more will be the change in R. More you change in temperature, more will be the change in R. And this is equation number 1. Now we can also discuss the RT minus R naught. Change in resistance also depends on the initial resistance. If initial resistance is large at 0 degree Celsius, so the change in resistance must also be large. So this is equation number 2. When we combine these two equations, 1 and 2, so we get RT minus R naught is proportional to del T into R naught. So if we remove the proportionality, we are left with the RT minus R naught is equal to alpha R naught into del T. So if we say that RT is equal to R naught, plus alpha r naught into del T. So RT is equal to R naught into 1 plus alpha into del T. So finally, if we remove, because we know that the resistance and resistivity are proportional, so it means, so if we can also convert this resistance to resistivity, just rho T is equal to rho naught into 1 plus alpha into del T, 1 plus alpha into del T. So we can also write rho T is equal to rho naught 1 plus alpha into T minus T naught. T minus T naught is the change in temperature. Okay. Now we describe. I will discuss this formula. Last equation number 3. So in this formula, the terms, the first term, that is rho naught, is resistivity at 0 degree Celsius. Resistivity at low temperature, not a 0, because sometimes low temperature is not 0. It might be minus 10. It might be minus 20. It might be 2. It might be 1. So it's at a low temperature. R rho naught is the resistivity at low temperature, rho T is the resistivity at high temperature, because when temperature increases, the resistivity at high temperature is rho T, and alpha is the constant, that is known as is a thermal expansion coefficient, thermal expansion constant, or something we can say that this is a constant of proportionality alpha. So it alpha depends on the different materials. Okay, different materials have different values of alpha. Okay, and T minus T naught is the change in temperature. This is del T, change in temperature, change in temperature. In the next question is example 7. We will discuss how to apply this equation. For example, if we have the different values, then we can find we can apply this equation in order to find different values. Okay, thank you.